In this video, I'm going to talk about Hibernate flushing. So what is flushing in Hibernate context? Why can it become a performance problem for your application? How can any performance problem in this area be prevented? And in particular, how they were solved in the context of the content lifecycle management. So flush is an essential Hibernate operation. And it can be too slow by itself. It can be called too frequently. Of course, if any of those appear, your code can be affected when it comes to performance. And in particular case of the content lifecycle management, we had both of these problems together. So why is flushing needed? In order to answer this question, I have to talk a little bit more about how Hibernate works under the hood. So first of all, remember, Hibernate is an object relational mapping framework. It's a library that tries to simplify the developer life that has to use an object-oriented language, in particular Java, to do operations on a relational database, which is a very common scenario. So it tries to reduce the impedance mismatch between the relational world and the object world. In fact, you can think about code like this. This is used to get data from a database. In this case, we're getting information about the patch, and to change data in the database. In this case, we're updating a particular attribute of the patch that we've retrieved. So if you squint a little bit, you might think that Hibernate transforms the code into this SQL code, retrieving data and updating data. Now, of course, this doesn't work. Why? What Hibernate actually does with the first line of code is to run the select query. This really happens. But the update doesn't really happen because I forgot to do one thing, which is to explicitly tell Hibernate that I want that change to be set. One might ask why. Why didn't Hibernate run the update right away? And the reason is that there might be, your code might do several changes to the same object that you want to persist with just one command. Of course, this is a silly example, but in more complicated cases, you can easily imagine that a single object might be changed by different code paths for different reasons, and in the end, you just want one correct update command reaching your database for obvious reasons. Now, if you try to run this, you would expect the select and the update to happen, but this again doesn't work. And it doesn't work because I forgot to do one extra thing, which is flushing. So when working with Hibernate, you have to specify, okay, I am done with updating a certain object, which is done with the update method. There is also the delete method that does the same when we want to get rid of something. And then you want to batch together many changes and flush only once. So when you flush, you're telling Hibernate, hey, take all the changes I've done to any objects that you're tracking and put all those changes back into the database in as fewer commands as possible. So that's also the reason why flush has this name. So this will actually work. So flushing, what it does is basically to align the state of the database to the state of the objects that are known by Hibernate. Here I've used this term hibernated objects, but this is not correct jargon. It's just something I came up with. The correct jargon for this would be the Hibernate cache. So the Hibernate cache is a persistent is a structure in Hibernate. A collection, basically, actually something very close to a hash map that holds all the objects that are known to Hibernate. So what flushing does is to reflect the state of the Hibernate cache to the database. How can an object enter the Hibernate cache? Because this is not very explicit and confuses a lot of people. I have a lot of objects in my application, but not all of them are actually in the Hibernate cache. Which ones are in the Hibernate cache and which are not? Here I have some examples. If you load an object by using the session get or session load Hibernate methods, those objects are automatically in the cache. If you query the database by using one of the available Hibernate ways to run queries, like the criteria query, JPA, HQL, or SQL. SQL depends on the configuration, but that doesn't matter. Any object that gets back to you from one of such queries is by default also in the Hibernate cache. As I said, there are ways to configure that out if you don't want it, but generally what you can expect that anything you get out of a query through Hibernate is cached. Also, if you create a new object, is not in the Hibernate cache by default, but if you save it, then it enters the Hibernate cache. And finally, if you already have an object that has a collection, and that collection is hibernated, so already part of the cache, you add something to that collection that enters the cache automatically. So those are the main ways an object can enter the cache. And now once it's in the cache, the next time you flush, any change goes into the database. Now you might wonder, why didn't I see this flush method very often? And the reason is, by default, we flush and we also commit to the database at the end of each HTTP request. So in general, you don't want to flush or commit in the middle of an HTTP request. You want to get your objects, work on them, and then having something automatic in the framework of all things that flushes and commits for you, which is the right thing to do. But in some cases, you do have to care. Now, this is the reason why flushing exists and what this function is, but why can it be slow? Shouldn't it be fast? Now, I don't have a very clear answer to this question, but what I know is that flush might take quadratic time to run in the number of objects in the cache. So the more objects in the cache you have, the more time it takes to run the flush, and that time is quadratic. So you really have to pay attention not to have too many objects in the cache at once, because if that happens, flushing will take a lot of time. How can you prevent that? Well, of course, one easy solution is to avoid using the Hibernate cache whenever you have a very big number of objects, and resort to SQL to do heavy batch processing instead of doing this process in processing in Java through Hibernate. Now, Hibernate not only is an object relational mapping framework, it also allows you to do SQL queries directly bypassing the cache and everything else. So you can do that. You can also use mode queries. As I said, in the Uyuni code base, we have this second framework to send SQL queries, which is called mode queries, and you can use it. Or you can use store procedures in a very worst case from my perspective. So those are the typical ways to reduce the number of objects that are in the Hibernate cache, thus making flush reasonably fast. We have also mentioned that flush could be too frequent in other cases. So maybe flush time is not that bad, but you're calling flush a lot of times, and then you get into a performance problem. When is it called? Well, of course, it's called if you invoke it explicitly, but there are also implicit cases in which flush is actually called under the hood. First of all, if you are doing queries, by default, flush happens immediately before the query. Why? Because you might have at some point of your code a lot of objects that are in Hibernate cache. You might have updated some of them. Then you run a query and you expect the database to already reflect that. But that's not the case. So in order to avoid easy mistakes, what Hibernate does for you by default is to automatically flush before any query under the hood. So you run a query and you don't really expect it, but at that point in time, a flush automatically happens. And if you run a lot of queries, that can mean you will have a lot of flushes. It's also important that the mode query framework that I've mentioned a couple of times already also flushes every time a mode query is called, and that was not non-configurable before this work. So every time you run a mode query, you get a flush. And how can I reduce the number of calls to this method? Well, first of all, you should try to avoid interleaving queries, especially mode queries, and the use of normal Hibernate objects, because every time I interleave them, I get flushes and they can be heavy. And the second way is to just disable auto flushing. Now, this works at least for queries that go through Hibernate, not the mode query framework. So if you disable them, then you get, of course, less flushes. But you have to keep in mind that the state of the database might not reflect the state of your objects, because at this point you don't have that insurance anymore. You have to be careful when you code that you don't assume that the database immediately contains everything without explicitly flushing, since you've disabled automatic flushing. Now, it goes without saying that in the specific case of the content lifecycle management features that I've mentioned, we had both these problems. Flushes were heavy and they were also frequent. And I basically had to use all of the techniques that were mentioned in order to reduce the weight of flush to the total runtime. Now, we can take a look at the specific patches that were developed. One of the important missing pieces that I didn't really mention in detail is that we already have a helper method, which is called do without auto flushing. And what this helper method does is to disable auto flushing. So if you have a piece of code and you're really sure that the code inside of it doesn't require automatic flushing, doesn't require flushing at all, you can use this helper method to disable auto flushing in a certain section of code. You have to be careful, of course, because this could be error prone. But if you know what you're doing, using this helper method basically disable all flushing, but at least for Hibernate queries. And this is an example of that method being used in the patch that was in the pull request that I've shown. What you do is just you open a block with do without auto flashing, and you put whatever code you need inside. This can also return a value if you need so. And it's up to you to make sure that code inside this for loop, in this particular case, behaves well without auto flashing. In this case, it was almost the case, and just a couple of fixes were needed in order to make that true. This was one of the tricks here. The other trick was that up to this pull request, do without auto flushing wouldn't affect mode queries. So mode queries would always and anyways flush. So if you had code in here which used mode queries, and there's a lot in here, you wouldn't get the benefit of do without auto flushing. Thereby, you didn't get much of an improvement with just using this helper method alone. So what was done in this case, let me see if I have the patch here. I should have it. Yeah, here. Was basically to teach mode query code to respect do without auto flushing. I can show it by changing the commit that I'm looking at here. The patch is not easy to see, but deep inside the mode query framework code, there is this particular method, DoWithSolving connection, that basically wraps all of the SQL interacting code. And here you can see there was a non-conditional flush. And what I handed here is just the condition, so that, if the helper method that we've seen before is active, the flush would be skipped. And this allowed us to skip quite a lot of flushes and actually gain a good part of the performance that you can see here. And this is it for this video. In the next one, I will talk more about SQL query tuning, in particular in the context of PostgreSQL.